Hi there, I'm Tom Pepperkamp, a platform product owner. That's right, platforms should be treated as products. Platform engineering is a new and rapidly evolving field. To help you navigate this space, I've created a video series that dives into the why, what, and how of platform engineering. This series pulls together insights from top quality public resources, organizing them into focused topics to create a crash course in platform engineering. Each video is curated to support your platform engineering journey, offering practical knowledge and insights to deepen your understanding of its principles and potential. Let's get started. Throughout my talk, I'll be referencing content from leading voices in our industry. A big shout out to these rock stars for their amazing blogs and conference talks. You'll find all the sources listed at the end of the video. These references aren't just for ethics, they're packed with valuable insights that I highly recommend exploring. So, if you enjoy this video, definitely check them out and dive deeper. Welcome back, everyone. Today, we're focusing on a crucial tool for modern software development, the Internal Developer Platform, or IDP for short. Imagine a world where developers can self-serve everything they need: environments, deployments, databases, observability, without waiting on other teams. This is the power of an IDP, a developer-centric platform that transforms how teams engage with their organization's delivery configuration, driving autonomy and speed. In this episode, the longest and most technical episode of the series, we'll not only define what an IDP is, but also explore the available design patterns that shape these platforms. Are you ready to join me on my search for understandable models to guide essential stakeholder conversations? This video follows up on my previous video, Why Platform Engineering is the Natural Evolution of DevOps. If you haven't seen it yet, go check it out. In that one, we talked about how platform engineering helps developers deal with the crazy complexity of modern software delivery. It's all about making things simpler by abstracting away complex infrastructure. Remember, we talked about how a full-stack DevOps approach isn't always enough in today's complex operational landscape. The solution lies in reducing cognitive load, a central idea we explored through the lens of platform engineering product teams, backed by team topologies concepts. By enabling developers to focus on delivering value rather than dealing with complexity, platforms become the foundation of successful organizations. We defined platform engineering as a way of thinking and team of teams design. This summary from Weaveworks, a cloud-native pioneer that unfortunately closed shop early 2024, paints a more detailed picture. Now, first, let's find out how platform engineering differs from IDPs and how these terms relate to each other. We'll use Microsoft's Introduction to Start Right, Stay Right and Get Right as a right start for this video. Why? Because it puts DevX at the center of platform engineering. Microsoft describes platform engineering in their white paper as a movement that improves the experience of developers and supporting teams. Microsoft also uses the words practice and a cultural shift to describe platform engineering. Platform teams offer developers a curated set of tools, capabilities, and processes to start right, stay right, and get right. To start right, developers need easy access to tools and systems that comply with organizational requirements. They stay right through automated governance and policy. To get right, the organization needs to think of developers as an internal customer and look for ways to improve their experience. Let's try to connect some dots. Platform engineering is a movement, a practice, an approach, a cultural shift, a way of thinking with DevX as the focus. And platform teams offer platforms to developers as internal customers. Platforms to developers as internal customers. Shuffle this a bit, and we have an internal developer platform. This visualization provides a nice introduction to what capabilities an IDP brings, but I'm pretty sure that you're here for something less conceptual. So let's dive into that. Sometimes it's easier to say what something isn't. So first things first. An IDP is not just a wrapper around a cloud service. Is that controversial? I think not. Although leveraging cloud services effectively is a key component of a successful IDP, IDPs are not about enabling operators to do the things they already do. IDPs are about enabling developers to do the things they're not expert in doing. Internal developer platforms mean enablement. IDPs streamline processes, increase productivity, and enhance developer experience by enforcing standardization and enabling self-service. They positively impact key DevOps and DevEx metrics. Wrappers don't do that. Also, Kubernetes is not an IDP. Kubernetes is an abstraction on the infrastructure that helps automate many important but mundane and labor-intensive tasks that were being done by many teams across the industry over and over and over again. Kubernetes provides a container-centric management environment. It orchestrates computing, networking, and storage infrastructure on behalf of user workloads. This provides much of the simplicity of platform as a service, PaaS, with the flexibility of infrastructure as a service, IaaS, and enables portability across infrastructure providers. That's all great, but it's not an IDP. Organizations should build IDPs on top of this Kubernetes layer to reduce developers' cognitive load instead of shifting the immense cognitive load of cloud-native ops to developers. In the words of Kelsey Hightower, Kubernetes is a platform for building platforms. It's a better place to start, not the endgame. Now, it's time to build those platforms on top of the Kubernetes platform. So today, we'll unlock the power of platform engineering and discover the key to faster innovation and streamlined development with internal developer platforms, IDPs. So, what is an IDP? Let's start with the Container Solutions blog post by Kari Liebenberg. She gives us two starting definitions to consider. We start with Martin Fowler's often cited definition of a digital platform. And Humanitech has this definition of the Internal Developer Platform, IDP. An Internal Developer Platform, or IDP, is a self-service layer that allows developers to interact independently with their organization's delivery setup, enabling them to self-serve environments, deployments, databases, logs, and anything else they need to run their applications. Kari Liebenberg builds on these definitions and states, an internal developer platform, IDP, can be seen as a specific implementation of a digital platform, offering self-service functionality as a product to meet a variety of a team's needs. The focus for an internal developer platform is improving the release process that teams need to follow to release software. Sounds good, right? We'll have a look at how the release process of modern teams look like and what these teams might need later. Now that we know what an IDP isn't and how we define it, let's see what one actually looks like. Developers usually interact with IDPs using APIs, CLIs, and web-based portals that provide access to the platform's capabilities. One example is Backstage, an open source platform by Spotify. It helps create internal developer portals, which are like a one-stop shop for developers to access and manage all their software, tools, documentation, and services. Another example is Port. Unlike Backstage, which is opinionated in its structure, Port's blueprint approach allows greater flexibility for customization. It launched in 2022 and has seen rapid early adoption due to its open nature. This is not necessarily an internal developer platform. What you see here is an internal developer portal. Developer portals are the first touch point, but they are not your IDP. Let's have a closer look at the differences between internal developer platforms and portals. First, the platform. An internal developer platform is a thing, a product people use to do platform engineering, built by platform teams. An internal developer portal is a component of an internal developer platform. It's a single pane of glass for ClickOps and visibility. By the way, backstage from our first portal example is essentially like a toolbox that gives you the components to build your ideal developer portal. Port can be more than just a portal. It's a ready-made solution with a focus on infrastructure management. It's the internal developer platform that reduces the cognitive load on engineers, developer toil, and manual work, not the service catalog or the developer portal on top of it. Without actual self-serviced offerings, a portal is just a Wizard of Oz experiment, with no more value than ticket ops. And couldn't we better focus on managing those services instead of managing requests from people to do something? Building the house first doesn't mean you can't think of the door, the portal yet. A wireframe or mockup can help with decisions about structure and with roadmap conversations. For example, you can access the Backstage UI kit in Figma to duplicate your own version and play around with a fitting homepage for your own organization. Now, let's have a look at the capabilities and benefits of an actual IDP. What's behind the portal? IDPs provide a service layer that abstracts the complexities of application configuration and infrastructure management. They are the automation and abstraction of modern ops. Remember from our previous discussion on platform engineering, the goal is to reduce cognitive load for developers. IDPs achieve this by abstracting the complexities of application configuration and infrastructure management, allowing developers to focus on writing code and autonomously delivering high-quality applications. The very same Kelsey Hightower, a Kubernetes thought leader, gave the opening keynote at KubeCon 2017. In his inspiring talk 7 years ago, he already suggested this abstraction layer to avoid noise for developers. Kelsey Hightower demonstrated a developer flow free of any implementation details. In a spot-on article on Cloud Native Now, Justin Rioch cited, again, Kelsey Hightower. Kubernetes is not a tool for developers. They can use it, but Kubernetes is low-level infrastructure and works best when people do not know it is there. Today, we are often in the opposite situation. Many developers are painfully aware Kubernetes is there. If done right, Kubernetes would become invisible and just an implementation detail. Git push over kubectl apply. Do your developers have to write YAMLs and use kubectl to do their work? And what do they think of that? What does the developer workflow actually look like? A modern developer's workflow has 3 major stages: code, merge or ship, and run. To elaborate on that, what might a modern team need to release software in the cloud? The aforementioned blog by Gary Liebenberg gives us some clues. To name some capabilities, a team probably needs a repository to store code, pipelines that will run when code is updated, automated scans that run when the pipeline runs, which might include security checks, code quality checks, and running tests, and the creation of ephemeral environments. In addition to the release process is the run model. That is, where will the application run and be maintained? This in turn leads to needing infrastructure for running the software. The infrastructure layers to consider include networking. How is traffic handled? What traffic is allowed? What ports should be accessible? What should be public? What should be private? Compute. Is the team using VMs, containers, or going serverless? Storage. Where is the data going to live? How is the data going to remain secure? what, and who can access the data. Observability. What is happening across your solution? Who is accessing your systems and what changes are being made? How healthy are your systems? How well are your systems performing? What alerts will help your team? Security. What access control is in place? What checks and scans for security vulnerabilities? That's a lot of shifted left ops stuff that devs now have to worry about. IDPs to the rescue. An IDP not only supports the run stage, freeing developers from the ops burden, but also supports the code and merge stages. It provides technical documentation, templates, CI/CD pipelines, roles and permissions, and other essential tools. This comprehensive support streamlines the entire development process, enabling developers to focus on writing code and delivering high-quality applications. To dive deeper into the stages of code, merge, and run, let's look at this Gartner diagram. The diagram breaks down the capabilities of an IDP into 3 key stages: discover and create, integrate and deploy, and operate and improve. Do you see how these 3 stages match with code, merge, run? In the discover and create stage, an IDP can support developers with capabilities such as documentation, templates, and IDEs. These tools help streamline the initial coding process, ensuring that developers have everything they need to start building efficiently. Moving to the integrate and deploy stage, the IDP can provide CI/CD pipelines, infrastructure automation, etc. These capabilities ensure that code changes are seamlessly integrated and deployed, reducing the risk of errors and speeding up the delivery process. Finally, in the operate and improve stage, the IDP can offer monitoring, logging, and other capabilities that help maintain the health of applications in production and provide valuable insights for continuous improvement. By unifying these disparate platform capabilities, an IDP not only takes care of the traditional ops domain, the run stage, but also provides comprehensive support throughout the entire software development lifecycle. This holistic approach enables developers to focus on delivering high-quality applications with greater speed and efficiency. It's important to note that IDPs can indeed cover the full spectrum, but not necessarily do so. It's a collaborative journey together with the platform users, the developers. More on this journey in my Platform as a Product video, where I cover the Tennis Viable Platform TVP subject. The IDP as an abstraction layer allows developers to self-serve the resources they need to build, test, deploy, and monitor applications with minimal friction. IDPs are designed to maximize software delivery throughput. The goal of an IDP is to enable developers to focus on writing code and delivering high-quality applications without having to worry about the underlying infrastructure setup and maintenance. An internal developer platform should be built to eventually cover these core self-service. I repeat, self-service. Capabilities: cloud infrastructure orchestration, role-based access management, application configuration management, deployment management, plus environment management, and application observability to enable that goal. One more time for the people in the back. Platform capabilities means self-service. Self-service with guardrails. Now, let's look at some real-world examples of what that means. Internal developer platforms enhance the developer experience by streamlining day 1 and day 2 operations. Provided self-service capabilities should cover both initial setup tasks, day 1, and automating ongoing development and maintenance processes, day 2. It's a pitfall to only focus on day 1. Day 2 is where developers spend most of the time. Here's an overview of some day 1 and day 2 operations examples, but I won't dive into this level of detail today. This one is for the marketing folks. From a user perspective, an IDP that takes care of both day 1 and day 2 operations provides a platformless experience, enabling developers, data scientists, and others to focus on code and innovation. Platformless allows developers to streamline their development process and concentrate on building apps that deliver value to users. This doesn't mean platforms won't exist. It means that the complexities of a platform don't need to be handled by application developers. Instead, the IDP provides a seamless or transparent platform experience. Do not leak your implementation details into the developer workflow, remember? The suffix less in tech signifies a shift towards increased simplicity and a more user-centric design approach. Less, as in without the burden. Platformless, the realistic and sustainable version of NoOps. We talked about the why of platforms, and we've looked from different perspectives at the benefits, the what of IDPs. It's time to describe how an IDP looks like. A picture is worth 1,000 words, right? What we need is a blueprint, something to kickstart conversations and explain our IDP. Without a visualized reference, it's difficult for the platform engineers and product owner or product manager to avoid misunderstandings. And it also helps the platform team with their stakeholder communications. And there are more benefits. Some kind of high-level architecture or model also helps to clarify boundaries. Think of the AWS shared responsibility model. More on shared responsibility models later. Now, let's try to find a suitable blueprint for our IDP conversations. This graphic from the Cloud Native Computing Foundation, CNCF, Platform Engineering White Paper, illustrates the relationships between products, platforms, and capability providers. The direction of consumption in this diagram is top-down, showing how capabilities are consumed by platform interfaces, which in turn are consumed by product teams. I think this graphic can certainly serve as a reference and conversation starter, but not the one to translate the what of IDPs into a how. What other options do we have? This picture is from internaldeveloperplatform.org, an educational hub to promote IDP principles. It illustrates how an IDP connects infrastructure, application configurations, and the management of environments. The illustration is limited to the environment management capability and doesn't cover the full IDP scope. Conclusion: not suitable for a broader conversation. Next. One of my favorite YouTube channels is DevOps Toolkit. Check out Victor Varsik explaining the parts of an IDP in this screenshot. Key takeaway: all those things are tailor-made for specific developer needs. This implies that our architecture should support a high level of customization. The illustration in this video is informative. It tells us the role of an IDP as the bridge between the desired state, code, and the actual state, but it lacks the structure to paint all IDP building blocks. Let's move on. Victor Varsik's statement that IDPs are tailor-made is supported by Gartner. Don't expect to buy a turnkey platform. We'll evaluate a more extended platform diagram from Gartner later, but before we move on, please take note of the automation emphasis in this version here. This diagram from a blog on the Equinix website illustrates some of the capabilities typically found in IDPs to simplify and streamline the software development lifecycle, or SDLC. The author, James Walker, emphasizes that successful platforms must be flexible and scalable enough to support your development operations without compromising on security or compliance. This requires platforms to support all the technologies you're using, including hybrid and on-prem environments, in addition to your cloud resources. Although the blog post is extensive and a valuable resource, and I do like to focus on the different roles interacting with the platform, I think the illustration is too limited in its structure. Back to Gartner. This diagram is what we can expect from Gartner. High level and abstract, designed to present a conceptual model rather than granular, actionable details. The strength of this diagram lies in how it shows that an IDP isn't mandatory. Reusable IaaS and PaaS components are also directly available to product and service teams as X as a service. A powerful representation, but unfortunately not the level of abstraction we're looking for. I think we can stop searching. This is what a true platform blueprint looks like. McKinsey presented this blueprint at PlatformCon 2023 in their talk, Platform as Code, simplifying developer platform design with reference architectures. This architectural blueprint with its 5 main planes is a great conversation starter for a wide variety of stakeholders. Let's have a closer look at the planes that make up an IDP. The blueprint has 5 planes. Developer control plane. This is the primary configuration layer and interaction point for the platform users. Components include APIs, CLIs, and web-based portals. Integration and delivery plane. Contains the tools that build, store, configure, and deploy requests coming from the developer control plane. Resource plane. Contains all resource components necessary to run the app. Monitoring and logging plane. Provides real-time metrics and logs for apps and infrastructure. Security plane. Manages secrets and identity to protect sensitive information. How awesome would it be if we could relate our product backlog items to the corresponding planes on the blueprint? This graphic by the team from platformengineering.org presents well-known tools from the cloud-native tooling landscape plotted on the 5 planes. Isn't the structure great? I certainly think so. But how do we know which tools to select? There's so much choice. And there's a whole lot more in the Cloud Native Toolbox. This overview from the CNCF shows just how much is out there. It can be a maze for developers, but it's a candy store for ops folks. Platform teams can pick and mix in the ops candy store. Like Victor Varsik said earlier, IDPs are tailor-made for specific developer needs. It's important to note that it's the platform team that carefully selects and integrates this curated set of tools, capabilities, and processes packaged for easy consumption, ensuring they fit well together and align with the organization's standards. This careful picking is precisely to avoid the risk of fragmented or incompatible toolchains. The goal is to create a cohesive, efficient, and user-friendly platform that supports developers in their work. This requires a product mindset, where the platform team continuously iterates and improves the platform based on developer feedback. The subject of a product mindset is covered in a separate Platform as a Product video. Instead of doing your own picking and mixing, you can also start with predefined configurations. There are open-sourced reference architectures available for different platforms. Here's an example of an IDP reference architecture based on OpenShift that outlines the 5 planes of the blueprint we've discussed earlier. How might this architecture fit into your existing workflows? Another example designed around Azure services. Now that we've seen reference architectures as examples, let's explore how you can use them practically. Humanitech doesn't only offer open-sourced reference architectures, they also enable you to fork the code for the full IDP implementation, including learning path and a white paper. You can start setting up an IDP yourself easily with the open-sourced reference architectures. Fork the code for a complete IDP implementation, explore the learning path, and check the accompanying white paper. I highly encourage you to discover and explore some of the available reference architectures. Or use the available Google Slides presentation template to start for yourself with an empty blueprint and perhaps even create your own reference architecture. The tools on the reference architectures are representative and can be swapped with what you're using today. Imagine mapping out your architecture on those 5 planes and co-creating a golden path with your developers. How exciting would that be? Did you know that the CNCF also started an initiative to collect reference architectures? They might not use the blueprint with the 5 planes, but check them out anyway. Here's a core truth about platforming. It's not just about the tools. It's about how you organize and structure your codebase to empower developers. Thoughtfully structuring repositories leads to clear ownership, standardized configurations, and the grouping of related services. One optional component of the integration and delivery plane deserves some special attention: a platform orchestrator. So let's take our looking glass. Before we have a close look at orchestrators, it's worth noting that the necessity of a platform orchestrator can vary. For smaller teams or less complex environments, the overhead of implementing and maintaining an orchestrator might not be justified. In such cases, simpler automation tools or manual processes might suffice. The decision to use a platform orchestrator should be based on the specific needs and complexity of your organization. For more complex environments, a platform orchestrator might be a solution for the missing middle, as Daniel Bryant calls it. Looking at these models, this middle seems to have a prominent spot. But what is this orchestration middleware, and what problem does it solve? Daniel Bryant noticed that both developer-centric top-down and ops-centric bottom-up IDP approaches have their own pros and cons, and suggests that orchestration can combine the best of both worlds as an abstraction layer in the middle. I can hear you thinking, another abstraction layer? Let's elaborate on that. This abstraction is basically a platform API as a bridge between the developer's interface, portal, Git, and the infrastructure. No more infrastructure as code YAML for developers. It's time for a renewed look at this Gartner diagram, now through an orchestration lens. Conceptually, it certainly makes sense, don't you agree? Let's dive into a specific problem an orchestrator can resolve: multiple ephemeral environments. A platform orchestrator sits at the core of a dynamic internal developer platform, enabling dynamic configuration management and developer self-service. It drives standardization by design. Using a platform orchestrator, you can move away from static setups and can now orchestrate deployments and infrastructure provisioning in harmony. Configuration baselines let you drive standardization by design, abstracting complexity away from developers, yet without removing the necessary context in their delivery workflows. Instead of having a static YAML CI/CD workflow using YAML files that are manually localized to the context. A dynamic approach pulls apart the environment agnostic from the environment-specific elements of your configurations and ties APA configs to infrastructure configs. The platform orchestrator reads this declarative application model and deploys the application. Depending on your situation, the differences between static and dynamic IDPs might be worth further exploration. You can start with the reference resources at the end of this video. You have already heard the term golden path several times now. Time to explain the concept. A golden path is basically the answer to the question: what is the best way for developers to do X in our organization? Golden or paved paths are predefined routes in a platform that outline the best practices, steps, and required tools to achieve a specific goal. The golden path should be self-service, but in the way your developers want. As we discussed in the platform engineering video, reducing cognitive load is crucial for developer productivity. Golden paths contribute to this by providing well-structured pathways that minimize the mental effort required to build, deploy, and run applications. There are many other definitions of golden paths available. I'll share 4 more of them because they all emphasize different elements. The golden path is the sweet spot between giving developers complete freedom and putting developers in a cage for fear they will do something wrong. This definition can be rephrased as a mantra: golden paths over cages. Here's another one. Golden paths are ways for developers to do things by themselves, but in a way where platform engineers have baked the organization's standards in. This definition emphasizes autonomy to self-service and compliance, standards baked in. The next definition is from the insightful Build Golden Paths for Day 50, Not for Day 1 talk by Caspar von Grünberg at PlatformCon 2023. Any procedure in the software development lifecycle a user can follow with minimal cognitive load and that drives standardization. This one emphasizes the full SDLC. Golden paths aren't just for day 1 operations. If developers follow golden paths, then everybody wins. If using the platform and following paths is not a must. In my upcoming Platform as a Product video, I'll elaborate on the subject of compelling platforms. It's important to balance standardization with the need for flexibility. While golden paths offer streamlined and efficient workflows, developers may occasionally need to deviate from these paths to address unique challenges or innovate. A proactive and open attitude towards these off-path flows can be beneficial. Instead of viewing deviations as disruptions, embrace them as opportunities for further IDP development. By actively seeking feedback and understanding why developers go off-path, the platform team can continuously improve and adapt the platform to better meet the evolving needs of its users. This approach ensures that the platform remains both robust and adaptable, supporting a wide range of developer needs while maintaining high standards and consistency. The fourth, or actually fifth and last definition, is from Spotify, one of the pioneers in platform engineering. The golden path is the opinionated and supported path to build your system, and the golden path tutorial walks you through this path. Opinionated means standards and tools are built in as a convention. Supported means the platform team keeps it working and updated and provides customer support. This last definition emphasizes the maintenance and support by the platform team, including a walkthrough tutorial. In platform engineering, the internal developer platform, IDP, typically comes first as the foundation, and the golden path is then built on top of it. The IDP provides the underlying infrastructure, tools, and capabilities that developers can leverage, while the golden path defines the opinionated, streamlined workflows or sensible defaults for using the platform effectively. However, these can evolve in tandem. Golden paths may influence the design of the IDP by clarifying what developers need most, and the IDP's capabilities can expand to support new golden paths. When developing tutorials for golden paths, it's important to keep in mind that the primary job of the tutorials is to walk onboarding engineers through the golden path. You do have to think about the way to present the tutorials in the developer control plane, in the portal. Spotify has chosen an approach with one golden path tutorial per engineering discipline. It doesn't have to be done this way. For example, I could imagine a more modular approach, with one golden path tutorial per engineering job to be done. How can we use golden paths in conversations? Like with IDPs, it would help us to have a powerful structure, lingo, and visualizations. Here's one concept, shaped by Quatix. The heart of Quatix, a framework for building platforms, are so-called promises. Via promises, platform engineers can codify their organization's policies and opinions, security, compliance, etc. into the X-as-a-Service software supply chain, making it easy and straightforward for application teams to consume the services via the IDP. Other orchestrators have similar concepts but different terminology. In this video, I use Quartix as an example because I love the clear language of contracts and promises, a lingo that my stakeholders easily understand. A promise is a contract between the platform and its users. It describes a reusable component with organizational standards built in. Designing the right promise for a single service allows platforms to be built incrementally. The value of your platform increases dramatically when you offer application teams tailored golden paths. Creating a golden path with a system based on reusable components is easy. Decide on, define and install the individual promises that are required. Then define a higher level promise that brings those individual promises together. How does this sound? A complete development environment setup. Networking, integration, security, governance, compliance, and deployment, all available on demand. What do you think of these easy to understand visualizations? I bet you can use them to kickstart golden path conversations with your teammates or stakeholders. Gregor Hopi came up with a beautiful metaphor to describe the difference between single service and higher level promises. Imagine you have a basket full of various fruits. While each fruit has its own value and can be enjoyed on its own, the real magic happens when you combine them into a fruit salad. A higher level promise, a golden path, is like that fruit salad. It takes those individual building blocks and curates them into a cohesive, integrated experience, reducing complexity and ultimately providing more value than the sum of its parts. I hope this metaphor can help you have fruitful conversations. One more thing. We started this video with a tweet from Kelsey Hightower stating that Kubernetes is a platform for building platforms. It's a better place to start, not the end game. Then we went on a journey towards the end game, but we haven't talked about our starting place. See, do you know what's missing in the IDP blueprint? The platform itself. What you see here in the architectural blueprint is what's offered to the platform user, the developers. The foundation of it, the platform itself, isn't included. This makes sense from a platform user perspective. Remember, they want to be platformless. However, from a platform point of view, it's crucial to visualize the underlying infrastructure and services that support the IDP. This helps in understanding the full scope of the platform and ensures that all components are well integrated and maintained. In his Extending the IDP Reference Architecture talk at PlatformCon 2024, Max Gerbacher discussed the multiple dimensions and different perspectives of platforms and suggested extending the architecture with what he calls userland, the platform capabilities that form the foundation that carries the IDPs. For example, we include namespace observability in the IDP, but we also have observability in place for the platform as a whole. By extending the architectural blueprint to include the platform's foundational elements, we can provide a more comprehensive view that benefits both developers and platform engineers. This visualization can serve as a valuable reference for ongoing development, maintenance, and optimization of the IDP. Another extension Max Gerbacher suggested is a standardized way to define platform services. We've all seen the treat your platform as a product statements by every leading resource in the industry. But how can we describe what this platform product actually is? More on this in my upcoming video. A third and last suggested extension is from an organization viewpoint. One could say that locations would be a more suitable name to better align with, e.g., the operating model canvas (OMC), but an architectural view from such a perspective could be an additional layer in our quest for visualized conversation starters. We see a similar approach in another Gartner diagram about the topic of platform engineering. Compared to Max Gröbiker's suggestion, this diagram provides another level of abstraction. The outer circle includes data center infrastructure, edge infrastructure, and cloud infrastructure, focusing on different locations and their roles within the platform engineering landscape as well. An IDP blueprint isn't the only layer at which we can start dialogues. Do you see value in other suggested layers? Do you miss a dimension or perspective? One perspective I would like to add is responsibility. AWS came up with this so-called shared responsibility model. It helps customers to carefully consider the services they choose, as the responsibilities vary depending on the services used. A high-level IDP architecture can be a powerful tool for defining a shared responsibility model for your platform services. Here's how. Each component becomes a logical boundary for responsibilities. It's also possible to define ownership across planes. The blueprint also makes explicit which standardized aspects the platform abstracts, platform team's responsibility. It's even possible to use an outcome-based dimension and tie each layer or feature of the platform to, e.g., reliability, security, or velocity, enabling the shared responsibility model to focus on collective goals rather than siloed concerns. An example. For monitoring and observability, the shared responsibility model might look like this. The platform team provides a centralized logging and metrics solution, ensures it scales, and defines standard dashboards. Application product teams configure application-specific metrics, set appropriate alerts, and respond to application-related incidents. You build it, you own it. And a shared responsibility for aligning SLIs, SLOs, and refining monitoring practices. Would clear boundaries, visualized in a shared responsibility model, help you with your conversations? Wow, you've made it all the way to the end of this video. Great job. You should now be able to explain the concepts of internal developer portals and golden paths and how they can enable developers during the software development lifecycle. We've seen many different models with different perspectives, which we can use in our conversations with each other and with our stakeholders. To sum it all up in an elevator pitch, internal developer platforms, IDPs, are transformative tools in platform engineering that streamline software development by automating key tasks and providing self-service capabilities. By reducing cognitive load and enabling developers to focus on meaningful work, IDPs drive efficiency and innovation, ultimately delivering greater value to the organization. Embracing the principles of platform engineering and adopting a product mindset ensures that these platforms continuously evolve to meet the needs of developers. Join Luca from platformengineering.org as he recaps the concept of an IDP for you.
All right, so what is an IDP? Well, an internal developer platform is a set of tools and technologies that a platform engineering team binds into a golden path to enable developers self-service along the entire lifecycle of an application. By providing developers with self-service option while driving standardization, IDPs significantly boost productivity through a reduction in waiting time, distraction, or just manual work for operation teams. A recent benchmarking study we did on platform engineering has shown that IDPs are the single biggest driver to help an organization innovate faster and slash time to market. There is no one-size-fits-all for IDPs. The platform at a large retailer in the States will differ widely from the platform at a startup in Berlin. But there are still clear patterns in the design of modern IDPs, and they can be divided and described by 5 planes. The exact designs of those planes differs by organizational preference. First, we have the developer control plane, which clusters the primary interfaces developers can choose to use when interacting with the platform. Such an interface could be a workload specification for a fully code-based interaction, a developer portal for a UI-based view, or an API and CLI. The integration delivery plane contains the flow of a request from the interface all the way through to the running application with all its configured resources. It includes CI pipelines, a platform orchestrator, maybe a dedicated CD system, and sometimes dedicated infrastructure control planes. The resource plane encompasses all cloud and on-prem resources. This includes compute, databases, file storage, or DNS. The security plane includes policy layers and secrets management, and the observability plane, logging, and APM functionality. If you're a developer developing your application with a state-of-the-art internal developer platform, you should be able to self-serve everything you need to build, deploy, and operate your application and resources. It's important to point out that this goes way beyond the creation phase of a service. Well-crafted platforms treat every single deployment like day zero and create application and infrastructure configurations dynamically with every Git push. This ensures consistency and standardization across the entire lifecycle of your application. Well-designed IDPs follow a platform as a product approach, where a platform team builds, maintains, and continuously improves the IDP using product management principles and best practices. So why would you need an IDP in the first place? Most organizations already have an IDP, actually, whether they realize it or not. The question is whether it's a scalable, enterprise-grade IDP. A modern IDP ensures standardization by design, enables developer self-service, and reduces cognitive load on developers. It can help organizations innovate faster, shorten time to market, increase revenue growth, and improve customer satisfaction and retention.
Thank you for watching. I hope you found this session insightful and engaging. If you have any questions or would like to discuss platforms and platform engineering further, feel free to reach out. Your feedback and thoughts are always welcome and appreciated. Stay tuned for my upcoming video on platform as a product, where we'll dive deeper into how adopting a product mindset can enhance the effectiveness of your internal developer platform. We'll explore how this approach ensures that platforms are not only technically robust, but also user-centric and continuously evolving to meet developer needs. I look forward to seeing you in future videos. Thank you for sticking around to the end. The remainder of this video contains an overview of all resources used. There's some great stuff out there, often with references to even more great stuff. Are you ready to go down this rabbit hole?